In this lecture, I will share very important points about electric charge. How a body is charged electrically. First of all, let us recall that every material is made of atoms, and an atom is made of nucleus surrounded by electrons. The nucleus contains protons and neutrons. We know protons are positively charged and neutrons have no charge. Similarly, electrons have negative charge. It must be noted that number of protons in an atom is always equal to number of electrons in the atom. So total positive charge in an atom is always equal to total negative charge in the atom. Thus, net charge in atom will be 0. As the material is made of atoms and each atom is neutral, so whole material can be said to be having no charge. Now, how this charging of a material body takes place? For that purpose, I will have to take an example. Suppose this is a woolen cloth and I have a glass rod. When I rub these two bodies against each other, then what happens? Transfer of electrons will take place. The glass rod has electrons which are loosely bound. Glass rod has loosely bound electrons. And woolen cloth has comparatively tightly bound electrons. When we rub this rod against woolen cloth, the electrons will get energy used for rubbing against the friction between the two. By getting this energy, the loosely bound electrons start moving towards the woolen cloth. That is, transfer of electrons takes place. Transfer of electrons from glass rod to woolen cloth. It means glass rod loses electrons and woolen cloth gains electrons. Now electron has negative charge. It means woolen cloth will be negatively charged and glass rod will be positively charged. This is how charging of bodies takes place. Means charging is nothing but the game of electrons. It is a transfer of electrons that gives rise to charging of material bodies. Now the next question is, how much charge is produced by rubbing of two bodies or by any method? This magnitude of charge developed is calculated by a formula Q is equal to Ne. Q is the symbol used for charge. E stands for charge on one electron, and Q represents charge on body, total charge, and here N represents number of electrons transferred. If n electrons are transferred from one body to the other, then magnitude of charge produced will be Q equal to Ne. In case of previous example, on glass rod, how much charge will be produced? It will be Q plus Ne. In case of woolen cloth, if n electrons are gained by it, charge produced will be minus Ne. Means the magnitude of charge on both the bodies will be same, but sign will be opposite. In general, we can write charge developed is equal to plus or minus N into E. And means charge is quantized. Means charge on a body is always an integral multiple of charge on one electron. So this is called quantization of charge. Quantization of charge. Let me take an example. Suppose 25 electrons transfer from one body to the other, 20 electrons, and question is how much charge will be developed on the body. Means we are given n is equal to 20 and E is magnitude of charge on one electron. It has fixed value 1.6 into 10 raised to power minus 19 coulomb. Coulomb is SI unit of charge. So charge developed on the body due to transfer of electrons can be calculated as N into E, that is 20 multiplied by 1.6 into 10 raised to power minus 19. So this will give us 32 multiplied 10 raised to power minus 19 coulomb. This is how we can calculate charge developed on a body due to electrons transfer. Now let me introduce another important thing that is called conservation of charge. Conservation of charge means total charge on an isolated system remains conserved, remains unchanged. Let us go to previous example. The charge produced before rubbing the glass rod and woolen cloth. How much charge was there? On glass rod it was neutral, no charge. Woolen cloth also had no charge. So total charge before rubbing was 0. And after rubbing, charge on glass rod, suppose it is plus Q. Charge on woolen cloth, suppose it is minus Q, because magnitude will remain same. When I simplify it, I again get 0. So this is an isolated system consisting of glass rod and woolen cloth. This is how we can understand conservation of charge.